Hi everyone! Today we're here at the University of Miami College of Engineering 2024 Senior Design Expo. My name is Alexandra Bothy. I'm a junior studying mechanical engineering, and today we're going to be interviewing the different senior design groups.
Awesome, and hello everyone. My name is Trevor. I'm also junior like Alex. I'm studying industrial and systems engineering, and I'm originally from Mechanicsburg, Pennsylvania. This is my third time attending the Senior Design Expo, and every single year I'm blown away by all the different projects and everything that all the different groups come up with. Essentially what the Senior Design Expo is a lot of the engineering students are given up to a full year to work on their projects, depending on which individual discipline you are a part of. And then from there, they basically today is their day to present all their projects, ideas, and everything that they've been working on throughout the past year or the past semester. So we're super excited to be interviewing some of the groups today. Awesome.
All right, I'm going to get started with our first group. Hi, I'm Alex. Could you please introduce yourself and tell us a little bit about your project?
Yeah, so I'm William, and we're working on a EMG sensor type thing. This is Jungwoo, right? Say hi. Dan. We're all electrical engineering majors, so what we decided to do is we decided to work on this prototype thing that he's wearing, right there. So we have, the goal of this project is essentially what we're doing is we're sensing electrical signals on the muscle and then using that to detect what kind of contractions you're doing. The idea is that we want to use this for things like VR, robotics, prosthetics, things like that. So we think it has a wide range of applications in industry. So yeah, that's the basic.
Thank you so much.
Awesome. So next we're heading to an industrial and systems engineering group. This is my discipline, so I always get a lot of excitement interviewing a lot of the different students. So really quickly, introduce yourself and then tell us kind of about your project.
Okay, so I am Suleiman Liasin, this is Steven Sanchez, and this is Joseph Scalacci, and we're working on the OHLA construction company project.
I got nothing else to add. Well said.
Yeah, it was a good experience working with them. It was a fun time.
All right, so tell me, what was the biggest challenge as part of working on the project, and what were some of the major milestones that you guys wanted to hit when you guys were working on it?
So the major part is visiting the construction sites that we had to go to and collect some data, and that gave us some kind of exposure on what the real-world construction jobs are like, involving industrial engineers. And some major milestones that we hit were like constructing the Power BI dashboards, as you can see on the screens and the poster, where we developed a new cost tracker that can optimize the total cost of each project, and then also update and improve their project tracking process.
Awesome. Well, thank you guys so much. All right, passing on to Alex now for the next group.
Okay, our next group. Hi, would you please introduce yourself and tell us a little bit about your project?
Yes. My name is Anu. We're the Hemo Movers, and our project is about for hemodialysis patients. They have to sit 3 to 4 hours. So our goal is to increase mobility in those patients by designing a linear actuator motor. So it's going to go back and forth and move their legs to increase the mobility and help decrease the restlessness that they might feel.
Thank you so much, Anu. That was great. All right, Trevor's going to take us with our next group.
All right, so here we have Hate Wet Socks. And so really quick, I'm going to have one person introduce themselves and then also tell us about their project.
How's it going? My name is Matthew Bertman. I'm an environmental engineer in the CT department. So our project was kind of a combination of two different parts. The first part of our project focused on remediating some large flooding areas we see on campus, both by the engineering building as well as in other locations in some parking lots and in Memorial Drive right between the library and the Cox Science building. The second part of our project revolved around building a new engineering building for the engineering department. And yeah, I'm going to let Will talk a little bit more about that.
Yeah, so my name is William Collis. I'm a civil engineer. I was the civil transportation lead on this project. So I'll kind of expand a little bit on that part too. So we are designing a new building in the College of Engineering. It's decked out with new classrooms, teaching labs, research labs. We recently just got a big research grant in the College of Engineering, so there's definitely going to be more space for research required. We've also got some really cool educational engineering features. So like on our, we have a roof garden as a part of our building, and it's got an integrated rainwater harvesting system. So that means that rain that's going to land on the roof is going to enter a storage tank that's on our first floor, and it's going to be pumped into the first 2 floors' bathrooms. So our system is aiming to service like every 1 in 5 flushes on those first 2 floors. So it's part of our attempt to reach LEED Gold certification, and it's just an educational feature that we can show off. But yeah.
Awesome. And then one last thing, what was your favorite aspect of working either as a team or just what did you like most about working on this project as a whole?
I would say nearing the end, because obviously it's a lot of work putting the project together, but as we near the end, we start putting the pieces together and it really comes together as a full project, especially with being two kind of separate projects combined into one larger project. I think that was probably my favorite part, where we saw it all come together into one large project.
Awesome.
Yeah, our projects are kind of unique in the CAE and CET department because they're interdepartmental. So we have people working on MEP, FP systems, so that's more of like the architectural engineering side. We have like myself working on the civil engineering, so that's civil water, civil transportation. We have Matt, who's the environmental engineer. We have a structural engineer. So it's really interesting to see everybody kind of like bring their specialties to this group, and to see it all come together it's super awesome. It's been a journey last year, I can tell you that much. But
Awesome. Thank you guys so much. It looks great.
Thanks for
so,
stopping by.
of course.
Hi, yeah.
All right, so here we have the dean of the whole entire engineering school, so he's going to introduce himself and kind of talk a little bit about the Senior Design Expo.
Hi, Pratim Biswas, Dean of the College of Engineering, also professor in Chemical, Environmental and Materials Engineering.
Awesome. Yeah. And so what is your favorite aspect of kind of overseeing everything that's been taking part into kind of creating our Senior Design Expo every single year?
Right, so this is just fabulous, gets better year to year. The best part that I like is you actually have demonstrable products and projects, and that is just fascinating. I also enjoy that so many others like myself can come and enjoy this expo.
Yeah. Every single year it's my favorite aspect of whenever I get to come and work it, but also to see all the different projects, so I totally agree. Anything else you want to kind of lead
No,
everyone
this is
with?
great. I would encourage everyone to come and look or even see recordings, and shout out to neighborhood school kids. Engineering is the way to go, and everyone else on the campus community to come and enjoy the Senior Design Expo.
Awesome.
Yeah, good. Thank you.
Thank you so much. Appreciate it. Awesome. All right, now we're going back to Alex.
Thanks so much, Dr. Biswas. So now for our next group, would you please introduce yourself and tell us a little bit about your project?
Right. Hey, so my name is Diego Jimenez, and basically what we did is that we worked alongside a company called CareMax. CareMax is a company that provides medical transportation to Medicaid patients from their homes to their respective medical centers. As you know, Medicaid patients are usually people that are 65 years or older, so the majority of them can't drive. So this is why CareMax decided to add the option for those patients to solicit transportation from their homes to the medical centers. And so basically what we did is that we analyzed the way that they dispatched and coordinated these trips, and basically found different areas of improvement as to how we could facilitate the process for these dispatchers to coordinate the pickup and drop off trips.
Thank you so much. And what was your favorite aspect about your project?
So I personally liked getting to know the associates, the dispatchers that worked in CareMax, and getting to know where the pain points are for them in their process. And then we were able to provide them recommendations that could help them on the day-to-day, which is what I love about industrial engineering.
Thank you so much, guys. Great to talk to you. Now Trevor's going to take us to our next group.
All right, so here we are with our next group. Really quick, I'm going to have you guys introduce yourself, the project, and then tell us a little bit about it.
Sure. So hi, I'm Fabiana. I'm joined by Liam, Matthew, and Tristan. And basically we're working on the electric short takeoff and landing vehicle for autonomous relief, also known as SFAR. So we're hoping to address natural disaster in areas like South Florida, using this autonomous vehicle to sort of drop off some care packages for people who are stranded or need some really quick assistance during events like hurricanes, floods, and things of the sort.
Awesome. And then can you tell us about some of the biggest challenges that you guys face when creating this?
Some of the biggest challenges we face would be really calculating the different parameters we need to minimize weight of the care packages and the structural components of the SFAR, as well as also determining the sourcing and the pricing of the different components we would need, and just kind of getting the entire scope and envelope of the rescue operation we want and would desire to kind of like optimize our performance and stack up against the current methods of rescue and aid operations in flood-based scenarios.
Awesome. Well, thank you guys so much. Enjoy the rest of the expo. All right.
Thanks so much, Trevor. So now for our next group, excuse me. Whoop. Sorry, we're just doing a quick interview here. Hi, everyone. Would you mind introducing yourselves and telling me a little bit about your project?
Yes. I'm Daphne Ricketts. I'm Olivia Bark.
I'm Carlota Sagardui.
And I'm Valentina Vega.
And tell me a little bit about what you're doing here today.
Yeah, so we are Slumber Sleeve, and it's a way to mitigate nocturnal leg cramps. We have integrated sensors and motors for pain relief without waking up a patient while they're having nocturnal leg cramps.
Thank you so much. And could you tell me one thing you've learned from your project this year?
So I think we definitely learned how to problem solve because we came across a couple problems and we had to learn how to use a lot of different sensors and motors and how to use a different type of code with different type of electronics. So I think it was definitely a good problem solving experience, and it helped us learn how to do teamwork between each other but also how to improve ourselves.
Thank you so much. So nice talking to you, and great job, guys. All right, and on to our next group. Trevor's going to take over.
Awesome. All right, so introducing our next group, we have South Dade Transit Operations Center. First things first, Chris, do me a favor, introduce your group and tell us a little bit about your project.
Yeah, of course. So my name is Chris Papa. I'm the PM on this project, and we designed the South Dade Transit Operations Center, which is responsible for charging, maintaining, and operating 160-foot battery electric buses to support the need for the new bus rapid transit line along the South Corridor, which heads from Homestead all the way to Dadeland South Station. So yeah, our facility is supporting the needs for the new transit line.
Awesome. And what was some of the biggest things and lessons that you learned while doing the project, and what were some of the major outcomes that you kind of hope to accomplish through the project?
Yeah, of course. So I'd say the biggest thing for us is we're all individual engineers in individual disciplines. So for example, I'm like the civil roadway engineer. We have an environmental engineer over here, our mechanical, electrical, plumbing, our structurals person. So I guess it's all about coming together and having a cohesive project at the end. It was really a challenge that we overcame, but it was cool to all work together and produce a really successful project that we're all proud of at the end. So
awesome. Thank you so much, Chris and group. You guys did amazing. All right.
Right behind you. Thanks so much. Okay, and now on to our next group. Excuse me, would you please introduce yourself and tell us a little bit about your project?
Hello, I'm Jassim Al-Awad. This is
Hassan Al-Daraya.
Ahmed Al-Sheikh. We're Team 9. We're doing a face recognition system for entering classroom and buildings. Instead of using like physical cards, we use the face recognition.
Wow, that's really interesting. And what do you think was your favorite part about working on this project this year?
So I like that we used many features like Wi-Fi and Bluetooth, and we learned about the machine learning. So it combined a lot of things, and a lot of things that we studied, we get to implement them. So that was useful for us.
Thank you so much. It was so great talking to you, and great job, guys. All right, and now, sorry, are we this way? Now we're going to take a second and talk to our lovely Associate Dean, Dr. Nina Maville.
Hello.
Hi, Maville. What's your favorite? Oh, sorry, Dr. Maville. What's your favorite part about the Senior Design Expo?
Seeing all the students and them doing all their projects, and I really like before it opens that I get to talk to all the students because they've done some great things here, and I hope you all enjoy the projects they've done.
What's something you tell your industrial engineering seniors when they're working on their design projects?
To make sure that they figure out what the impact is of their project, and that's what's going to draw people to see what they've done. Because without impact, there's no point in doing the work.
Thank you so much. All right, now we're going on to our next group. Trevor, what have you thought about all the projects so far?
So honestly, like I said, I've been doing this for 3 years, and every single time I love all the projects. This year in particular, one of my favorite things is that a lot of the projects, they definitely constructed some definitely more unique, I would say, solutions than what I've even seen in the past. And all of the groups have been doing an amazing job. So we are at our next group already. So really quickly, tell us about your group, what you guys hope to accomplish as part of the project, and kind of just tell us a little bit about what you did overall throughout the semester.
Sure. So my name is Carlos Molina. I'm a master's student for the Industrial and System Engineering Department. In collaboration with Ryder, we developed this project that is a machine learning model that predicts the probability of show up for a customer in a vehicle. At the beginning of the semester, a data set was received and was prepared throughout the whole semester to implement in a machine learning model that has a great accuracy. And the results from that machine learning model are used to get the outputs shown here. There's a probability table that shows the probability for a given customer and vehicle, shift and date, and the same information is displayed in a calendar. This shows the same information in a compact view that is better to visualize the whole picture of the situation.
And so if you were to redo the whole entire project, would you do anything differently? Would you keep everything the same? Like, what would you change?
Well, I'll do more research on pre-processing because it was a big part of the project and it took a lot of days. That I'll probably have done differently in this case.
Thank you so much, and congrats for being alone. That's amazing. All right, passing it on to Alex and our next group.
Thanks so much. And now we're with our Solar Connect group. Hi guys, would you mind telling me a little bit about your project? Or introducing yourselves and telling me a little bit about your project?
Hi, my name is Chloe.
Allison.
I'm Andy.
And what is your project? Why did you do it?
So we built a solar aircraft that's going to provide LTE and 5G internet to underserved areas that don't have it.
And what was your favorite aspect of working on this project?
So we got to work with Dr. Zah, who was our advisor, and we got to actually use his technology, the CoFlow Jet, and we implemented that into our design. And it's brand new technology, so it was super cool.
And if you have any advice for incoming seniors who are going to do their senior design project next year, is there anything you would tell your past selves, anything you would do differently?
Definitely, ask the professors for help. All of them really want to help, and we asked multiple different professors to help us, and they love getting involved and helping us. So yeah, it was really cool.
Thank you so much. Great job, guys. All right, now Trevor's going to take us to our next group.
So one of the things I think it's really important to point out is you can see how popular and how many people are here, and I think that's a testament to how there's so many engineers and also non-engineers that come to the Senior Design Expo to definitely showcase all the different projects and see whatever the students have been working on. So the next group that we're going to be at, this is called Hip Track Patch. Awesome. So really quickly, introduce yourself in your group and tell us a little bit about your project.
Okay. So my name is Rebecca Menendez, and I, along with Leo, Colette, and Catherine, worked on Hip Track Patch. So the goal of our product is that we wanted to capture preliminary hip kinematic data and then create an algorithm system to measure step count. That's very important for patients that had just undergone hip arthroplasty and you want to gauge how much rehabilitations they need. So we were able to successfully do that through an algorithm system that could be passed to the doctors to study how much therapy that they're going to need over time.
Awesome. And so what is one really cool outcome that you guys discovered or some unexpected results that you guys had that you didn't maybe anticipate when you started the whole project?
I think something that we didn't anticipate is that there's a lot of other variables that we can study. So we focus specifically on step count. How much does a patient walk that might be a healthy patient or a sick patient? But there's also different variables that you can look at the knee. There's impact forces. Our joints are healthier because they're younger, but patients that undergo hip arthroplasty might have worn down joints, so that could also affect your gait as well, which is something that we can look at for the future.
Awesome. And then lastly, how do you see this potentially benefiting, other kind of areas of study, or just how do you see this maybe progressing if you guys were to progress any further?
Well, I would say that the end goal would be to get it to the development of the original track patch for the knee. So that would include having a temperature monitor to monitor inflammation of the joint, and that would tell you about the quality of the recovery. Integrating the joint angle calculations, having the patient do other exercises rather than just stepping, stuff like that, so that you could get a more well-developed understanding of the quality of the recovery after the hip arthroplasty.
Awesome. Thank you guys so much, and congratulations. Awesome. Passing it on to Alex for the next group.
Thanks so much, Trevor. Now we're here with SwiftJoin. Would you guys please introduce yourselves and tell me a little bit about your project?
Yeah, so I'm Gunty and this is James.
James, how you doing?
So what is your project today?
James, go for it.
All right, so basically we made a web application for optimizing the hiring process. The way that it works is we're focusing on temporary employment. So it basically allows more transparency between the potential candidate and the business. So on our website, you can find jobs, you can look for candidates, and we have a way to rate businesses have profiles and users have profiles. Businesses that had employees work at their organization can leave reviews on their user. Do you want to pull that up, the user profile? Yeah, okay. So if you look over here, Gunty's going to pull it up. This is going to be a user profile. So if you scroll down, you're going to have reviews from all the previous businesses saying, this guy was great, he did this, that, and vice versa for the business profile as well, and it allows more transparency between picking a candidate or picking a job, and gives you a better insight into work culture.
And what inspired you to work on this project?
I just kind of saw a need for it. It was something that I felt was missing from a lot of job search sites. If you look at a resume or you look at a job position at any company, there's no real way to tell what the experience is like working there, a first-hand account of how a person performs at any given position. So I think we're bringing something new to the market.
Thank you so much, James and Gunter. That was fascinating. All right, Trevor's going to take us to our next group.
Awesome. So the next group that we're going to go to is an industrial and systems engineering group. They worked with FPL. So really quickly, just introduce yourself and then tell us a little bit about your project and your team as a whole.
So I'm Ahmed Ali, ISE students. We worked, we teamed up with the mechanical engineering team. We worked about the FPL 1 bolt bracket, and we did the material selection and the installation manual and the street light replacement and solution. And the mechanical team worked with us and did the design and the testing.
And so how was it to work with another team that was outside of industrial and systems engineering? Did it make the process easier, more difficult? Did you learn a lot in the process?
Yeah, for this point that you talk about, like you learn how to communicate with other students, or like it's a little bit difficult for us, but we learned something new in this project.
And then what was maybe the biggest challenge that you guys faced throughout working on the project? Maybe besides, working with another group of mechanical engineers, what was the biggest challenge that you guys came across, with the FPL project?
Sometimes getting quotes from different manufacturing companies, they don't give us that quotes because we are not like companies, we are just students, and they need like company name and business name and something like that. So we found that is like the hardest part of the project.
Also, that it's difficult to get response. Like maybe you have to do several things in 1 or 2 weeks, and you should wait like 1 month to get response from the FPL. This is a big challenge for us.
Awesome. Thank you guys so much. You guys did amazing. Awesome. Passing it on to Alex now.
All right. Now we're here with our next group. Okay. Would you guys please introduce yourselves and tell me a little bit about your project?
Yes. Hi, my name's Christian Horgan, and our team, we worked with Florida Power and Light to create a solution to their 1 bolt bracket problem. So FPL's current streetlight brackets are designed to have 2 bolts going through each of the streetlights, and on some of the newer poles, there's only 1 bolt hole available. And as hurricanes and strong storms come through the South Florida area or all of Florida, the brackets tend to either rotate or completely turn upside down or spin off and completely fail. So our solution was this 3-piece kit that can be attached to any street light bracket on every single FPL light pole in all of Florida. So the main concept is just using a wedge design that as it gets tightened, the outside wedge will want to dig into the inside wedge, allowing the arms to get tighter around the outside of all the poles. And we've been working with FPL's interested in our project and are going to continue to make this project. So they're planning on making 10 to 20,000 of these in the upcoming years to give to contractors to bring out to these streetlights after hurricanes to reinforce these brackets, and so they'll never have to have maintenance ever again.
Wow, that's really interesting. I love the real-world impact of these projects. Now, could you tell me your favorite part about working on this project this past year?
Yeah, my name's Yanis. I guess one of my favorite parts was going to the FIU Wall of Wind, because we got to test our bracket, and our bracket withstood 156 mile-an-hour winds. So that's basically a Category 5 hurricane. And after we tested our bracket, we got to stand in front of the wall of wind, and we got blown away a little bit.
Wow, thank you guys so much. What a great job, guys.
All right, thank you.
All right, Trevor's going to take us to our next group.
Awesome. So what we just saw was an industrial and systems engineering group working with a mechanical engineering group. One of the best things about engineering is how interdisciplinary it is between all the different disciplines within engineering and how so many of them could overlap to kind of work together. Next, we're going to be talking to a group of biomedical engineers. This group specifically is called RG Blood. So first things first, really quickly, introduce your group. Tell us a little bit about your project.
Perfect. So first of all, my name is Juan Flechas. I'm here with Kevin, Valentina, and Vagif. They're my team. We're RG Blood. And basically what we're doing is being proactive over reactive. So a little fun fact, I don't know if you know, but 70% of all the amputations in the United States are due because infections is not encountered at an early stage. So that's what we're trying to do. With these biomaterials that we're able to develop, basically they get put on the skin and they will change color based on the pH of your skin or of your fluids. Now,
that color will change to color that you can see in this little rainbow. So usually the ideal pH in your skin will be of around like a 4.7 to a 5 pH. And then as infection appears, it will turn to a more basic pH, which will lead to the change in the biomaterial color to a more bluish purple color. So that's how we're able to detect infection at an early stage and save people's limbs and save people's lives in a more effective way.
Got it. So what were the major outcomes or kind of results that you guys found so far as part of the project?
So the major outcomes will be definitely the socioeconomic problems. So we're able to mass produce these gels actually at a very low cost. So as you can see here, we have a prototype of a small test at home kit, which right now it does consist of only a thermometer, thermistor to change for the temperature. And then on top of that, the COVID test that you can see at home that you're able to use in this past pandemic, you will detach this. It will be introduced into the pH indicator and this will change colors. Now with this test, you can actually save around $400 to $700 each visit to the actual hospital, like an ER. So that's what we're trying to target. This is mainly to target like the social, like the populations or low-income people that don't have access to that healthcare that everyone else has access. That's what we're trying to beat right here. We're trying to beat those socioeconomical problems between, let's say, people with money, people with insurance, and people who cannot afford an insurance. Because health should be accessible to everyone, and that's what we believe in. So
awesome.
Yeah, and that's our motto. Be proactive over reactive. Let's not wait until you have a problem to give it a solution,
Yeah, awesome. I love the product and I love the idea. One last question. If you were to redo the whole project, would you change anything? Is there any particular stop that you'd maybe spend more time on, spend a little bit more detail in a certain area? What would you change at all?
So we will definitely change the amount of time that we have for the prototype. So yeah, sadly this is, this for our class, at least for our department, we have a little more time than everyone else. We get 2 semesters, so a full year. But I mean, I think time will be a big constraint that I would like to have a little more in order to, get more resources, get more help, get more testing done to actually be able to make this happen at a bigger scale.
Well, even with the time constraints, I'm super impressed with what you guys did in a year.
Thank you so
congratulations.
Much. Would you like a candy?
I love it. Thank you so much. Awesome. Next, we're going to pass it on back to Alex.
All right. Thanks so much, Trevor. So now for our next group, would you guys please introduce yourselves each and tell us a little bit about your project?
Hi, I'm Reina. I'm a senior here, obviously, studying environmental engineering.
Hi guys, I'm Jack Wolf. I'm the lead structural engineer on this project.
My name is Eric. I'm the lead transportation engineer.
My name is Afnan. I'm the mechanical, electrical, plumbing, and fire engineer.
My name is Hussein, and I'm the environmental engineer.
Okay, and then can one of you tell me just a brief synopsis of your project?
So basically we had 2 parts. Our first part was looking at the University Village. It's been known to flood a lot if you know anything about it. Whenever it rains, there's like maybe a foot of standing water. And so we were tasked with trying to tackle that. So what we did was we took a survey of the existing roads. The green areas are the low-lying areas on the road, and it increases in height from there. So we were basically able to get perspective on where the water was flowing to prevent flooding. From there, we designed an exfiltration trench, which is basically a structure underneath the roadway that takes all the water and allows it to go through the ground underneath it. So we calculated a bunch of different lengths that are going to go under all these roads, which will hopefully help accommodate all the floodwaters.
Okay, on to the second half. So the Office of the Architect tasked us with designing a new College of Engineering. Basically, we designed a 4-story structure, which is around 69,000 square feet. It's a step structure. As you can see, we have green roofs on 3 of these steps. It includes around 16 research and teaching labs. The main thing about this is sustainability. So the green roofs, basically the rainwater collected through them will be exfiltrated through bioretention cells. We also have other green measures in the form of solar panels and LED light fixtures as well. Here's our structural system. It's primarily made out of precast, cast in place concrete, and then our mechanical, electrical, plumbing, fire protection systems. Can basically sum those up with the fact that our HVAC system is a centralized cooling system, and we have 1 air handling unit on each floor. So yeah.
Thank you so much, guys. That's truly fascinating. Now, could one of you tell me any advice you would give to students about to start their senior design project next year?
To try to work their best.
Try to do our best. All right. I'll keep that in mind. Thank you guys so much. All right. Now, Trevor's right here.
All right, we got a lot of people around this specific group must be doing something super exciting. Next group we're at is a mechanical engineering group. This is Erebus. Sorry to budge in, just gonna ask a few questions. So really quick, introduce Airbus, tell me all about it, and also introduce your lovely group for me.
All right, well, my name is Omari. Here we have Sam, we have Trevor, and we have Pedro. Essentially, with our project, we're trying to get more fuel efficiency out of an engine. We've been able to achieve 1%, but we think we can get up to 2.5% or even greater. We were limited by a faulty pressure regulator in our testing. It had a broken diaphragm, and we were not able to get as much efficiency as we hoped for because it was limited by the pressure. So essentially the way this works is there are two main cycles in engines. There's an Otto cycle and there's an Atkinson cycle. The benefit of an Otto cycle is you can get as much power as the engine can produce, but you lose fuel efficiency. An Atkinson cycle is more fuel efficient, but you lose power. So we devised a system where we can trap the air in there so we can get the same amount of power, but get the same benefits of fuel efficiency across all RPM ranges. Specifically, we're targeting cruising conditions where the pumping loop is the greatest so we can get the greatest efficiencies, but we believe our system can be used across all RPM ranges. So what that translates into is you're saving money when you pay for gas because your engine is more efficient and it can get the same amount of power out for less fuel, and you save money.
Awesome. And so you did this in about a year, right? 2 semesters?
Well, that's interesting. So our original project, we had to switch. So we spent a semester working on that. Halfway through the next semester, we had to switch to this project. So we really had a semester and a half. So we had to work double time to get everything in order. We had to read a lot more papers. We had to rewrite our whole paper. We had to do all of it over and over again.
Got it. And so besides that probably being a big challenge, right, what are some of the other challenges you face? And then what else do you think maybe having a more extension of time maybe would have helped you guys in the whole process?
Yes, definitely an extension of time would have helped us. I would say the other big challenge was with our advisor. He would give us a little bit of information at a time, and he wanted us to go find the rest of it. So it was mainly on us to learn. We had to read a lot of textbooks, a lot of papers to get all the information we need, which it was a slow process, but in the end, it helped us to understand what we were doing a lot more. So I enjoyed that.
Awesome. Thank you so much, and congratulations, Airbus team. Awesome. So next group we're going to be getting to is home automation using LOT. Here we go, Alex.
All right, thanks so much, Trevor. Okay, and now for our next group. Hi, guys. Could you please introduce yourself?
Yeah, my name is Senior.
Thanks.
I'm Auda.
And would you please introduce yourself?
My name is Abdulaziz.
All right, and could you guys tell me a little bit about your project?
Our project is home automation using IoT technology, which we think is the future. You have smartphones, so why not smart houses? Which is you're going to be able to control your whole house. Simple things as TV, lighting, even to security cameras and windows via an app. You don't even have to be at the same country or continent as your house and be able to control it. And we think this is the future, and we designed it to be simple enough for all ages because we know homeowners' ages varies from simple things as 18 to 60. So yeah, it's simple things as on and off, and be able to customize it to put a preference. Let's say you want the lighting to some dimension, you'll be able to set it so you don't have to say this, put on and off every time. So you have to customize it based on your preference. And yeah, we think this is the new future.
That's really fascinating. Now, could you tell me a little bit about what inspired you to work on this project?
What inspired me is the technology, the way we're heading. So doing a smart home is like the future and easier for like old people to control their home through their phone. And yeah, that was what inspired me to do this.
Thanks so much. And what was your favorite aspect of working on this project this past year?
We developed a new skill because as engineering students, especially electrical engineering students, we're more based about programming the thing, not based physically designing it. So designing the thing, we got a new skill, designing a 3D model house. So that was my favorite part, actually.
Thanks so much. That's really awesome. What a great job, guys. You should be really proud of yourself. Thanks so much. And now Trevor's going to take us on to our next group.
Awesome. Thank you so much, Alex. So our next group is fully centered around hybrid flow airfoil. So really quick, I know we have a lot of people here. Awesome. This is for the live stream. So really quick, I'm going to have you introduce yourself, the group, and then tell us a little bit about your project because it looks super impressive. So tell us a little bit about it and your name.
Okay, my name is Joshua Prabhahar, and I'm here with the hybrid flow airfoil. And this is an experimental airfoil that we designed here at the University of Miami. There is no other place that we know that has done something like this. And what we did here was to do away with the traditional airfoil and to design something that's not only different, but better in many ways. So we are able to actually increase the lift, reduce the drag, and we wanted to prove it both experimentally and numerically. So if you could bear with me a second, we can set up that demonstration for the live stream. So give me 1 minute and we'll get it up.
So while we're waiting for him to set up, tell us what were some of the biggest challenges that you guys maybe faced with a project of this scope and size?
Truthfully, the biggest challenge that we faced was with the wind tunnel. It's kind of fundamental when you're testing an airfoil and its capabilities with regard to airflow. But we were able to set up a low fidelity airfoil in the hallways of the College of Engineering when students weren't walking around, so on the weekend. And we managed to get really compelling numbers that proved our concept and even showed that we're kind of better than what's out there. And that's really the biggest challenge. Apart from that, we had a few like transportation issues, but that's kind of normal when it comes to working as a group. But
Awesome. And so for all of our viewers, who might not know what airfoil is, just kind of briefly explain what that is, just so we can kind of get a background.
Yeah. So an airfoil is essentially a cross-section of a wing. It's just like a slice. And as you can see here, we have an example of it. This is just a 2D view of what a wing would be. It would be a little smaller. Here we have a better demonstration, but the way that it works is that you have airflow going above it, airflow going under it. It's a little faster at the top than it is at the bottom, creating a pressure differential, and that's how lift is created, and that's how your planes work. So that's how an airfoil works. That's what an airfoil is.
Awesome. All right, so walk us through this amazing demo. Of course. So what is he doing right now?
He is currently pouring hot water into a cup, and he's then going to put dry ice in it so that you can see the actual air.
Okay.
And then we're going to put it right up to our demo right here. He's going to power it on, and you're going to see how the airflow goes into the suction slot and out the back where we have a jet flap. So, and here you can see how the flow, you can see the actual air coming out of the cup going into the suction slot, getting pulled in by a compressor, and then out the back is going to be that cold air.
Wow. How did you guys come up with this?
It was actually an iteration of what our advisor is doing. He does the co-flow jet, which is the reverse, where he has the jet flap at the top and then the suction slot at the trailing edge. So we just reversed it, and we found that it's almost as efficient, if not more. But of course, it's going to require a lot more research. Our research is still ongoing, but this is what we've been able to do in the past year.
Wow. Well, thank you guys so much. For what you guys did in a year, I'm super impressed. So congratulations. All right, awesome. Going over to the next group.
Hi, so we're going to take a quick break, and I'm going to, excuse me, just a quick interview. I'm here with Alan Sirkin. He's very involved in the College of Engineering, and I just wanted to ask you a couple questions. What's your favorite part of the Senior Design Expo thus far?
I just think it's so exciting to see that the kids, they're so stimulated, and they're so excited about their projects. I think it's just wonderful, and they're all, ready to go on to the next step, either grad school or get a job. But they're all gang-ho, ready to go. They're going to all be great canes. They're going to be like this.
It's all about you.
For the rest of their life.
Thank you so much, Alan. All right, and now we're going to go on to our next group. Thank you so much. I really appreciate it. Hi, guys. So, sorry to interrupt. Now we're going to interview our next group. Would you guys please take a moment and introduce yourselves?
Yes, my name is Juliano Plata.
And I'm Jose Abrams.
And I'm Yassine Arkulik.
Okay, and could you tell me a little bit about your project today?
Yes, we developed a home and roommate assistance app where you can hopefully find, match with the perfect house and the perfect roommate. So we tried to merge those, like a social media kind of, where it's less formal than relationship apps, like any Tinder or something, more for finding a housing mate,
Right. And is there anything that inspired this project in particular?
So it was based on when I went to New York City. I was helping my cousin find a roommate and house, and I saw that there was actually nothing in the market that integrated both aspects of the searching process for roommates and listings. So I just spoke with Giuliano and Yassine and came up with the idea of creating a streamlined a process for searching a house and searching a roommate. So based on the information that they give us in the platform, they're gonna match with a list of roommates and a match with listings that are within his price range or her price range.
Wow, thanks so much. And do you have a favorite part about working on this project?
A favorite part? Wow.
It could be anything. It doesn't have to be academic.
That's a rough one, but definitely senior work. I mean, ironically, none of us are computer or software engineering majors. We're all electrical. So taking on the challenge of developing an app, which we had never done before, and through a programming language that we also had never touched before, was a really good learning experience. And then you get the satisfaction of we developed it and it's working, and then we just see and envision it as something so much bigger. So it's something not just for us, but if we were to expand on it, work on a project, then people could get the whole experience of finding roommates in very difficult situations, where if they're traveling or moving into a new campus, things like that, and also help people who look to rent their place or houses have a platform where they can just post those things and make them more accessible to the people through a less complicated process.
Thanks so much. And I have one more question for you. Do you have any advice you would give to students starting their senior design project next year?
I would say start planning the divide and conquer. Any feature you want to add, make sure it's in your time budget, and assign a person and keep track. Both of your teammates should be doing the same. So I have to keep track of them. They should keep track of me.
Thanks so much. Really great job, guys. All right, Trevor's gonna take us to our next group.
Awesome. So next we have Breathe Free. So hello, really quickly, just introduce yourself and your team and tell us all about Breathe Free.
I'm Christina, and my teammates are Alexa and Estefania. We designed Breathe Free to be a sealed pipette-like device for use in cell culture studies. So a lot of the time in cancer research or other diseases, you have to dose your cell cultures with toxic chemicals. That can be kind of difficult because biohoods, which are designed to protect the cell culture from contamination, don't offer any respiratory protection to the researchers. You can use a mask, but that's not always 100% effective. This is to provide an extra layer of protection. The whole idea is to prep your chemical in a traditional vent hood, which does offer respiratory protection, seal it inside the device, carry the device from the vent hood to the cell biohood, and using this is our proof of concept. We do have a much nicer design that we did attempt to have 3D printed, but there was an error with that. But you take the device to the cell hood, you attach the dispensing cap that you need depending on what size of culture plate you're using. This is designed for a 6-well plate. You push the button and it dispenses to all 6 wells at the same time. So we're working on more designs for the different size of commonly used culture plates, but this is what we have so far.
Awesome. So tell us a little bit about kind of what outcomes you've seen so far, the results, and where you think, if say you had another year to do this project, right? Because senior design, you guys got a year, correct? So besides 2 semesters, if you were to continue this project, hypothetically, where do you think this could go further, and what kind of other further results do you think you guys could conclude from?
So right now we're getting about a 1% error in terms of dosing, and that's combining both the dosing and the dispensing cap. And what we would like to do is make everything a little smaller and lighter so that it's easier to hold in your hand, and we would like to make it wireless. Right now it does have to be plugged into a wall outlet for it to function. We would like to incorporate a battery and charging, and right now you do have to plug it in to program how much fluid you want it to give. We would like to add a keypad and make it so that you can program the device on the device itself.
Awesome. And then one final question, and this should be a fun one. What was the favorite part of working on the project, right? If you were to pinpoint one specific thing that you stood out to you as, okay, this was really fun, or I got the most out of this as an engineer, what would it be?
The brainstorming part and figuring out what we were going to do as a team. we had a brainstorming web of about 30 different ideas, and paring that down to, okay, what makes the most sense? What doesn't exist yet? What's a problem that has annoyed us in the cell labs? Because we've done research, and this has been a pain point. We're like, okay, we're engineering students, we're becoming engineers, let's fix the pain point that's been annoying us.
Yeah. Awesome. Thank you so much. So well spoken, and congratulations on your project. Awesome. So heading to the next group, passing it on back to Alex.
Thanks so much, Trevor. All right, and now we have our next group. Hi, guys. All right, so can everyone please introduce themselves?
I'm Nicole.
Joelle Solowaychuk.
My name's Jack Lee.
I'm Luke Bartholomew.
Luca Martinis.
All right, we got a big group here. So would you mind telling me a bit about your project?
Yeah, of course. So our client was the University of Miami, and our project was divided into two totally separate things. So one of our projects was designing a stormwater management system to fix flooding on campus, and we focused on 3 particular locations: Stanford Circle, Mahoney Pearson, and the area by the Business School Plaza. And so what we first did was we conducted a topographic survey of the site to get the elevations of the land, and then we figured out what the boundaries were contributing to each drainage area, and then designed a drainage infrastructure component for every single area to fix flooding in that location, and also at the same time fix stormwater pollution into Lake Osceola.
Wow, that's really cool. Now, would you mind telling me your favorite part about working on this project?
I think my favorite part of the project was just getting to spend so much time with my team. I mean, it was a really like a team effort. It was a super interdisciplinary project, especially like the new building that we designed. It required a lot of people being on the same page about a lot of things, and I think it was just a really cool overall experience.
If we have time, Jack should tell you about the second portion of our project.
Oh, we have 2 projects. Okay, go ahead and tell me the second one.
Yeah, so the University of Miami assigned us 2 projects. The second project being sort of a new College of Engineering building on campus. It would be in addition to the ones that are already existing. There's stuff going on down here that's renders of our building. It was an interdisciplinary project. We had to design the structural system, the mechanical, electrical, plumbing systems, the stormwater management systems, and as well as the architecture. So it's something that we're really proud of. A lot went into it, and yeah.
I have one more question for you. If there was anything you could do differently about this project this past year, anything you could go back and change, what would you do?
Yeah, it was all great. I think that it was really great to work with the University of Miami as a client, and as much as we did integrate with them, we collaborated with them a lot. It would have been even better to collaborate even more, but we weren't lacking that. It was just, you can always have more collaboration on that. So that.
Thank you so much, guys. Really great job. You should be very proud of yourselves. Thank you so much. All right, now Trevor's going to take us to our next group.
Awesome. All right, so heading over to our next area. Great, so here we have EduScan. Hi guys, so really quick, I'm just gonna have you introduce yourself and your team and tell us all about EduScan.
So I'm Elias Vitelek.
I'm Rainer Young.
Salman Alotaibi. And this is EduScan. It's basically a facial recognition system used in our example for the university to tell if students are coming to class or not, and then scan their faces and check it against our database. But this is mainly for professors, but can be used in any sort of other applications for like private companies or any other schools, anything where you need attendance to be used, really. So.
Awesome. And so what were some of your goals that you guys hoped to accomplish whenever you guys were trying to attack this problem or issue that you guys saw?
One thing that we really wanted to do with EduScan was try to bring facial recognition to a wider audience and a wider range of applications. As it exists, there is a lot of documentation on facial recognition already, but it's something that's kind of more, you'd only see in very high level, if you will, locations, top security, stuff like that. And we think that that's a waste. We see that the facial recognition is a very useful technology, and we wanted to apply it to something that could be implemented cheaply and widespread.
Awesome. So what was maybe the most surprising finding or results that you guys saw as part of the project?
Would you repeat the question again?
Yeah. What were some of the most surprising results or findings that you guys had as completing the project? What was the most surprising aspect of it?
Yeah, you mean the biggest problem we faced? Yeah. So the biggest problem we faced. So we have 3 phases here. We arranged it to finish it by the 24th of March,
and the last phase was the hardest phase, which is testing. So it's obvious that you can see errors in the codes sometimes. So that is the hardest phase we faced, but we solved all the problems and the device is working successfully now.
So last question, what was your favorite part about working as a team, maybe all together? Like, what was some of the biggest challenges, but as a whole, what was your favorite aspect of working all together?
My favorite part of working together was, I mean, this sounds pretty basic, but having the ability to delegate. It was we wouldn't have been able to do it without the team, really. Everybody brought their strengths, and it was really comforting to know that, I would do what I needed to do, but I had two other people who had my back that could help, and we could, do that with each other. Yeah.
Awesome. Thank you guys so much, and congratulations. Awesome. Passing it back to Alex.
Thanks, Trevor. Okay, now on to our next group. Excuse me, guys. Sorry, we just have a quick interview here. Sorry about that. Would you guys please introduce yourselves?
It's Raida.
It's Yusuf.
And Ababil.
And would you tell me a little bit about your project?
Yes, of course. So basically, we are working with a company that's for events. So every time that they have an event, they need to custom make everything from scratch. So basically, when we went to the company, this is the current layer that they have. So we have changed some stuff and changed the distance to create this. And we have saved 47.5 in the distance. As you can see here in the simulation we have found the bottleneck of the company. It's the wood cutting inventory. It's hard for them to make everything flow faster because it's manually. They need it manually. So we have changed everything with this machine. So now here, when we put the new machine, everything is more ergonomic and the work machine is gonna be faster, and we have saved $31,200.
And is there anything in particular that inspired you to work on this project?
Yes, because we actually love events. Who doesn't? And I kind of want to go and work with that company. So why not to go and find a solution to make each employee more happy and.
Thanks so much. And what was your favorite part about working on this project?
Actually, my classmates, they were so helpful and kind, and also the company. And our favorite part, to actually see the manufacturing place and look out the layout and take all the measurements.
Thank you so much, guys. Really great job. All right. Now, Trevor's going to take us to our next group.
Awesome. So we're actually going to go across the pond over to the next side to group number 26. Awesome. So next project that we have is called Fly Dead Leg. So really quick, introduce yourself. It looks like you're all by yourself, which is really impressive. So really quick, introduce yourself and tell us all about Fly Dead Legs.
Yeah, so I'm Gavin McKenna. I'm a software engineering senior here at the University of Miami, of course. My partner, John Griffin Kuntz, couldn't be here because he graduated last semester, so we worked on this and developed this last semester. Fly Dead Legs is a web application that we developed that hopes to revolutionize the charter airline industry. A lot of small charter airlines fail because of a problem known as dead leg or empty leg flights with no passenger or cargo. So as you can imagine, these airlines are missing out on revenues, wasting resources, wasting time on opportunities that they could be capitalizing on. So we provide an interface where consumers can come on and pilots can list their charter airline flights and gain greater market visibility to those consumers, as well as have an efficient booking process that they wouldn't otherwise be able to have. The small charter airline companies don't have the capital out of the gate to build a great tech infrastructure for efficient booking, so we're hoping to do that for them here.
Awesome. So you said you had a group member, and then you went solo, of course, because he graduated. What was kind of the different dynamic in that you saw throughout the project, having someone to work with, and then having to do it all by yourself? Kind of walk me through that.
Yeah, so luckily enough, we were able to complete all the tech development last semester. So this semester, it's just been about compiling the information, preparing the pitches, preparing the presentation, and so it's been a little bit of a struggle because he's got some files over here, I got some files over here. I got to pull that all together, but it's fun. It's good. It's been fun. Yeah.
Awesome. And then, what was the most surprising thing that you kind of found out through the whole process? Whether that be the results, whether that be throughout the actual process of working on it, all the different technology you used. What was the most surprising aspect?
Yeah. So I would just talk about kind of like the market that's available out there for charter airlines right now. That was the most surprising. When we were doing our market research, so all of these small charter companies had very, very poorly designed websites, minimal to no infrastructure for booking these types of flights. The only thing that we found available for booking empty leg flights for the small companies was simply a phone number and email they throw at the bottom of the website saying, contact us and we might have an empty leg available. So the market research was fascinating, and we realized how big of an issue this was and also how much of a market share there was to capitalize on.
Awesome. Well, congratulations, and especially since most of it was done by yourself. So congratulations. Awesome. So pass it back to Alex.
All right, so we're actually going to go this way. We had some technical difficulties before during one of our interviews, so we're going to go back and interview them again. Now, I have had such a fantastic time here today at the Expo. To see all these fantastic projects and such inspiration for me next year, it's really just such a blessing to be here. All right, guys, sorry to interrupt. We're back. So, like I said, we had some technical difficulties before, so we're going to interview these guys again. Would you please introduce yourselves again?
I am Luke Bartholomew. My name is Jack Lee.
Joelle Solowaychuk.
And Nicole Palada.
And I'm Luca Martinez.
Would you tell me a little bit about your project?
Sure. So it was a two-part project assigned by the University of Miami. I think Joel would be better equipped at describing the first project.
Sure. So the first part of our project was a stormwater management system. We designed a remediation plan for 3 flood-prone locations on campus: Stanford Circle, the Mahoney Pearson parking lot, and the Business Circle area, which is Cesarano Plaza. What we did was we did a site survey and then uploaded the data to ArcGIS to delineate the catchment areas. And then we sized new drainage structures for the locations and also managed the pollutant loading into Lake Osceola in the process.
Okay, so the second part of the project, really quickly, we designed a new building for the College of Engineering next to the existing MacArthur building. It was a complete design from the ground up, starting with the architecture, the structural, the mechanical, the electrical, the plumbing, the stormwater management. It was a very interdisciplinary project that required a lot of collaboration. It was really fun to do, and yeah, we hope everyone likes it.
Wow, great job, guys. And what was your favorite part about working on your project?
I think definitely like the collaborative aspect. I mean, all of the things that we're doing sort of fit together like puzzle pieces, and it was just a real pleasure getting to work with the people that I got to work with. So,
wow, what a great job, team. Thanks so much. All right, and now Trevor and I are going to go back to the other side.
Making our travels today. All right, so our next group is a biomedical engineering group. All right, so really quick, introduce yourself, your team, and tell us a little bit about your project.
Hi, my name is Ella, and I'm joined with Logan, Dominic, and Lucy. We are a team of biomedical engineers, and our company is called ABG Now. Whenever a patient is in the operating room, the emergency room, or if they're in a state of critical condition, something called an arterial blood gas analysis test is performed. This reads values like pH, PO2, PCO2, and it's really important to indicate to doctors the patient's state. There's 2 primary ways that this is done. One is a handheld device called the iStat, and the other is drawn from an existing arterial line, as you can see here, where the values are taken and they're sent to a lab similar to how you would have a blood test done. However, the issue with these existing methods is that they're expensive and they're inefficient. And if you're in a state of critical condition, you need to know these values at that exact moment and accurately. So that's how we have our device. This is our concept model, ABG Now. It slides onto an existing arterial line, and it's able to read the values of an ABG test in that moment, and it's all external to the patient. This is great as it saves time, it saves money, and it saves lives.
Thank you so much, Ella. Within the context of this year, what we developed was a preliminary type of ABG Now device that uses existing pH and PO2 sensors in parallel to be able to measure various liquids such as blood to be able to then measure these values over a period of time. As you can see, we were able to show that the sensors were individually and combined able to measure these values over time accurately with high precision. So in the future, we would like to then translate this preliminary product into our optimal ABG Now to then use the optical sensors in measuring these ABG values.
Awesome. So what was maybe the biggest challenge when you were going through the whole project? And if you were to redo anything or change anything about it, what would you do?
Our biggest issue was definitely financial limitations. Sensors are incredibly expensive, and it is a little bit beyond the scope of a senior design project to develop your own sensor, is what we've discovered. So that's definitely was our biggest setback, was sensors. So in the future, if we had additional funding, we would be able to develop our device, ABG Now, by using optical sensors or ultrasound sensors.
But within the context of this semester and this year, we're really proud of how we were able to simulate our optimal blue sky product in a existing capable way.
Thank you guys so much, and congratulations. Awesome. Passing it back to Alex.
Thanks so much, Trevor. All right, now on to our next group. All right, excuse me, sorry to interrupt, but we're just going to do a quick interview. All right, would you please introduce yourself and tell me a little bit about your project?
Yeah, sure. Hi, my name is Haibo, and I'm a computer engineering student. And my project is basically an iOS social media application. And so it has some basic functions, just same as other social media application on the market. You can post things, and you can like, dislike, or search user, and you have your own profile or something like that. But the main the main feature we got is we have like daily words as topic, so we encourage users to post content which is related to that topics. So in this way, I think even for the same topic, the people with the different cultural background or different age will post the different things based on their opinion. So in this way, like people can check others' posts to see how they see the topic differently with their own opinions. Yeah, something like that is the basic idea about our project.
Wow, thank you so much. All right, and now Trevor's going to talk to our next group.
All right, so we actually have some of my classmates up next, so I'm super excited to interview them. We have industrial and systems engineers. So really quick, introduce yourself and your group member and tell us all about your project.
Yeah, so hi. So I'm Dylan Torres, and this is Aziz. So we work with PNS, which is an insurance company based in Doral. Basically, they were a small company, and then they grew larger, so that grew some inefficiencies in their communications and operation systems. So we wanted to address that by implementing a standard across the whole company and implementing that a better way to communicate and to send data, basically.
Yeah, awesome. So for our viewers out there, most of industrial systems engineers, we only get one semester to work on it as opposed to two. So that's kind of the major difference as opposed to some of the other engineering disciplines. So tell us, since you guys only had one semester, how would it maybe having a second semester and a full year to work on this change the project or kind of improved it?
Okay, so as we mentioned previously, we only tested our alternatives in one department. I guess if we could have more time, we could test it in the whole organization, which is 15 departments, and from there we can see if our alternatives were the best, or can we dig deep into more root causes and to get more data and to save more money for the company.
Awesome. And then finally, what was your favorite aspect of working on the project? I mean, you guys are a great team, of course, the two of you, but what was your favorite thing that you guys did as part of the project?
We used the aspects of industrial engineers. We learned a lot. It was basically an industrial engineering project, so I feel like I'm working. I started working. You know, I don't feel as a student anymore.
So do you really feel like your courses at the university, whether that be through Dr. Maville, who we talked to earlier, do you think they really helped you prepare for the project?
Yeah, it was great, and they were very helpful. In the courses before the project and within the project, they helped a lot. Thanks everybody.
Awesome, thank you guys so much and congratulations. Awesome, next we're gonna talk to Alex.
All right, now we're actually not gonna interview one of the senior design groups, but one of our clubs on campus, who many of my classmates are in. So, Praveen, hi. Now we're gonna interview the American Society of Mechanical Engineers to tell us a little bit about their NASA Lunabot. So Praveen, take it away.
Hi, so this is our submission for the NASA Lunabotics competition. It's a national competition where NASA challenges teams to create a lunar construction robot. The goal of the competition is to create a berm structure, which is essentially just a raised bank of land, to protect any land sites from ejecta from launches. And so our submission here uses a bucket wheel system, as shown over here, using a 3D printed titanium from our own labs to collect dirt, lunar regolith, which is lunar soil, bring it over, drop it into the collection mechanism, you can see it moving, and deposit it onto wherever it needs to go to. So NASA has a collections zone, a deposition zone, and a travel zone, which you all need to traverse, and we'll be competing May 10th.
Wow, thank you so much. And Alex, could you tell me a little bit about what's your favorite part about being involved in a student org like ASME?
Yeah, so ASME has been a huge help to me as an engineer. I've been a part of the club for 2 years, and it's probably been one of the best extracurricular activities I've had, because it's taught me a lot about doing CAD, learning software, and altogether it's a great thing for students to get involved and to learn more than what's taught in class.
Wow, thanks so much, guys. As a mechanical engineer, this might be my favorite project. All right, Trevor is going to take us to our next group.
Awesome. So today we have a solo. He's going to tell us all about his project by himself, and this is pretty incredible that he did. You know, he's here by himself. But really quickly, introduce yourself and tell us about your project.
All right. So my name is Tyler Sweek. The project is called Bike Pulse, and basically it's a turn signal and brake light for your bike that uses your phone to control the brake light, left turn, right turn while you're biking.
Awesome. So what inspired this idea? How did you come up with it? And what were some of the major things that you wanted to kind of show today at the Senior Design Expo?
Sure. So I came up with the idea because I ride my bike to school every day, and I found it hard to communicate with drivers on the road. They have turn signals, we don't, and I wanted a solution to that. And I thought it would be great to introduce your phone as well to help deal with that as well.
Awesome. So walk us through. Is this through an app? Is this through, how is it kind of shown? You said it's connected to your phone, right? How is it connected to your phone, and kind of what aspect of the technology is being used?
Okay, yeah, so right now it uses Wi-Fi. So this is connected to the free Wi-Fi. And if your phone's on the same Wi-Fi, you can send a left signal, right signal, and the brake light is automatic by using a web app that we developed to send it over the Wi-Fi. And the accelerometer in your phone detects the braking, and the other two are manual. So.
And then if you were to continue, this project past senior design, right? Where do you see this going in the future? If you could expand on it, if you could continue working on it, where could this go in the future?
I think this would be a great product to sell commercially. You only have the physical component here to mount on your bike, and then the app would just be on your phone. It could also be used if someone wants to make a smart bike or something like that in the future. Just have this built in, and then just connect your phone on to it.
Awesome. Thank you so much. Congratulations to you. Amazing product. All right, awesome. We're going to pass it back to Alex.
Thanks so much. So now our next group is called Nalox Near You. Now, would you guys please mind introducing yourselves?
Yes, my name is Tyler Benjamin.
I'm Liv Nikolic. Sylvia Ortiz.
All right, and would you tell me a little bit about your project?
Right, so our project is a Nalox response network. It allows you to deliver naloxone to people nearby, and also creates a network of treatment options, as well as different nonprofits in your area.
And was there anything that inspired you to work on this project?
I think what inspired us was thinking about like Uber Eats and creating kind of like an Uber Eats for Narcan and trying to bring down overdose deaths in general.
Wow, and what was your favorite part about working on this project?
I enjoyed the coding. I had never done something like this, and it was definitely a step forward, a lot of trial and error, but it came out really cool in the end. So.
And I have one more question for you. Do you have any advice you would give to anyone starting their senior design project next year?
Start early. Get started very early.
Wow, thank you so much. What a great job, guys. All right, now if I can find Trevor. Trevor's going to take us to our next group.
Awesome. All right, so our next group is called Oasis Transportation Solutions. So hello, really quick, introduce your group and tell us all about your project.
Hi, so we are Oasis Transportation Solutions. Our project is to service Miami-Dade County as part of their new Strategic Rapid Area Transit program. They are expanding to include 100 new electric buses, and we were tasked with designing the transit facility that's going to house, charge, and then also maintain and operate these new buses for Miami-Dade County.
So tell us, what were some of the major outcomes that you guys saw as part of the project? You guys worked on it for a whole year, correct? So what were some of the major outcomes and results that you guys saw?
Some of the major outcomes and results we saw were we were able to fully design a maintenance and operations building. We did all of the plumbing, electrical, the structural from the ground all the way up, as well as the environmental and entire site design. This is a 20-acre site, so it was a lot of work for us to do. But we were able to really go in depth on the structural and the whole environmental aspect of things.
Awesome. And I know you said it was 20 acres, so I assume that was one of the biggest challenges. Can you name a couple other challenges and things that you guys overcame as part of the year-long project?
Yes. A couple of other issues we had was fitting the matrix specifically given to us by our client. This is a real project they actually showed us before we started designing, so it was also taking what was currently done by professional engineers and not giving them that, being able to give them something completely different, really add on to the design and what they were doing. So it was also nice to be able to see what a professional did and then work off of that to try and make it better almost.
Thank you guys so much, and congratulations. One of my favorite things about the Senior Design Expo is how there's a big mix of groups that are not only design their own products and projects, but also worked with other companies, and that's kind of what you're seeing right now. Next, we're going to pass it back to Alex.
Thanks, Trevor. All right, and now for our next group. Hi, everyone. Would you mind introducing yourselves?
Hi. My name is Remy.
I'm Davey.
And I'm Devin. Thanks so much. And could you tell me a little bit about your project?
Yes, so what we did is AVRS, which is Automated Volume Reduction System. So basically, yeah, so what it does is, do you drive? No. Okay, so I drive, and then I love music. I would always turn the music loud and, you know, make it happy. But I realize I miss a lot of sirens when the ambulances are nearby, just because my music was so loud. So I came up with this idea, and what it does is when the emergency vehicle is nearby your car, it will automatically dim the volume and make an alert that there is an emergency vehicle nearby, and that's basically what we're doing. Yeah.
Wow, thank you so much. I really like this project. Now, would you mind telling me your favorite part about working on this project this past year?
Probably the sleepless nights. Not my favorite at the moment, but then we look back at it and it's fun. It was fun making this reality, actually. Like, I never expected it to come out so well.
Thank you so much, guys. What a fun project, and I love the demonstration. All right, and now Trevor's going to take us off to our next group.
Awesome. So next we have maximizing fleet utilization for the U.S. government. So hello, really quick, introduce yourself and your team and tell us all about your project if you don't mind.
Absolutely. My name is Christina Cancio, and this is Carolina Hassel. And we are the Maximizing Fleet Utilization for the U.S. Government project. So essentially, we did a project with the Fleet and Maintenance branch of the United States government. That branch essentially services different types of vehicles, specifically government vehicles, and we were tasked with maximizing fleet utilization.
Awesome. So I see some big numbers up here, 133% increase in vehicle service, $400,000 increase in revenue per year. Tell us how you got these numbers, how did you achieve this goal, everything like that.
Sure. So we used simulation to map the current state of the process, and we also made 4 separate versions that show the different recommendations that we made being implemented. From the numbers in that, as well as machine learning, we were able to optimize their process, as well as create a 3-year-long schedule for preventative maintenance. And if they follow our recommendations, those are the numbers that are going to be yielded conservatively and comfortably. So there's potential for it to be even more.
Wow, very impressive. So tell me, how do you think your courses at UM maybe prepared you for this project, and how you really kind of were able to dive deeper into some aspects of it through our university as the resources, everything like that?
Absolutely. So I took a simulation course, and that really prepared me to get the groundwork of this done. Also, just our process management, quality management classes, it really pushes us to take a look at the process, ask as many questions as possible. i.e. in general, we have a philosophy of getting as much information as possible before making a decision. And that's exactly what we needed to do here to make sure it was as realistic and reflective of reality as possible.
Awesome. So this project, right, only a semester, because all industrial and systems engineering projects are only a semester. If you had a full year, what would you do differently? What would you add on to the project?
Oh, absolutely. So I think we would have addressed the parts inventory problem that they currently have. So making sure that each and every vehicle has all of the parts that it's needed the moment it comes in to get maintenance.
Awesome. Thank you guys so much, and congratulations. Awesome. Passing it back to you, Alex.
Thanks. All right. And now we're going to go on to our next group. Sorry to interrupt, guys. Would you have a chance for a quick interview? Sorry to interrupt. All right. Sorry. Would you mind introducing yourself?
I'm Adrian Ivansica.
I'm Alex Snow.
And I'm Brandon Rubio.
And could you tell me a little bit about your project?
So yeah, I could take over. So basically our project is a device that aims to give the user's location based on the reading of the magnetic field at that location. So we have a few components to the device. We used an Arduino to tie up the different sensors together. We used a GPS module alongside a magnetometer. Basically what we do is we create mappings of latitude and longitude grids, and then we take the magnetic reading of the Earth's field at that location, and then we use that to train a machine learning model on that data. Then with that machine learning model, when given a reading of the magnetic field, we can use that to predict the latitude and longitude of the user, given that reading.
Thanks so much. And what inspired you to work on this project?
One of our professors, Dr. Kizarov, gave us the inspiration. We thought it was a really cool project because it's something that hasn't been tested much so far. It's relatively new technology, and it has a wide variety of uses. So,
Thanks so much. Really great job, guys. You should be really proud of yourselves. Trevor's going to take it to our next group.
Awesome. All right, so here we have our next group. So really quick, hello, introduce yourself, introduce your group, and tell us all about iRetina.
Yeah. Hi, so I'm Minor Oriana. I'm here with Sylvia and Esme. And iRetina is essentially a neural network that's trying to predict the stage of diabetic retinopathy. Diabetic retinopathy comes in different stages, so you really want to get it like early on, because if you leave it alone for a while, it can, accelerate all the way to blindness, and you don't want that, obviously. So what we do is we take an image, and then we get the vascular vessels inside of the image, and we train the machine on that. Basically, after processing, we get the machine to predict what stage it's at. And so we train it first, and then we assess it and validate it on the data. And our accuracies came out fairly high, about like 97%. And we did good at predicting the mild stages of the disease, which current solutions on the market have trouble. They usually do moderate and after. So
Awesome. What inspired you to come up with this? Like, how did you come up with this idea, and what kind of led to this whole entire project being completed?
Yeah, so actually Sylvia's mom suffers from diabetes.
Okay.
And so we thought that there needed to be a better way to like assess and diagnose early on, because treatment, like how she got it later on, is way more difficult. So we just wanted to focus on those people who are missing out on the early diagnosis.
Awesome. And of course, you did this over a year, right? If you were to continue this project, further, hypothetically, what would you change? What would you add? Where do you see this potentially going in the future?
Yeah, we definitely want to apply it to an actual medical device. So maybe like a diagnostic pen or something that the ophthalmologist could use directly on the patient to really early and really easily tell, like, yeah, this is the stage that you have, or you don't have any diabetic retinopathy at all. So we want to make it simpler for those that are going to be using it. So that's essentially our goal.
Awesome. Thank you so much. Very well spoken. Congratulations. Awesome. So passing it back to Alex.
Thanks so much, Trevor. Wow, it's really crowded over here. A lot of great projects in one area. All right, and now our next group is U-Wallet. Excuse me, would one of you be able to, hi, sorry, we're just doing quick interviews. Would you guys be able to introduce yourself?
Hi, I'm Carice Hay. I'm a computer engineer.
Hi, I'm Kayla Ashley. I'm an electrical engineer.
Hi, I'm Nakeem Dunkelly Allen, and I'm a computer engineer.
And would you mind telling me a little bit about your project?
Yes, so our project is an app that digitizes the cane card here at University of Miami. It is the student ID, faculty ID, basically anybody affiliated with the University of Miami has a cane card, and we are building an app that allows for all the things that you'd be able to do with a cane card being centralized on your mobile device.
And what inspired you to work on this project?
I think we had a lot of inspirations, but I think the main one was that the cane card is an outdated system, and everybody walks around with their phone. People are always losing this cane card, and to reduce plastic waste.
And what was your favorite part about working on this project?
Okay, I would say my favorite part about working on this project would be learning a specific coding language, so I was able to contribute to the user interface and making the app look futuristic and user-friendly.
Wow. Thank you so much, guys. Really great project. You should be really proud of yourselves. All right, now Trevor's going to take us to our next group.
Awesome. All right, so we just have a couple more groups. Our next group focuses on net zero CO2 ethanol generator. So really quick, introduce yourself, introduce your whole entire team. It looks like it's just the two of you, but introduce yourselves and tell us all about your project.
Yeah, I'm Max Kilborn. This is Rafa. And we're basically trying to make a more efficient way to use ethanol, because right now the United States makes more ethanol than any other country in the world, but we don't really use it efficiently. We mix it with gasoline and put it in cars, and to do that, we have to get it to a high concentration, which requires a lot of energy. So we're basically trying to reduce that amount of energy required to produce the ethanol, and which makes it a much more efficient process. And he can talk about what we've been working on, the engine part. He can talk about how we've been designing that engine.
So the things that we tested is the cylinder heads. We measured on the flow bench to see the swirl and the flow going through it. And we also measured the compression ratios to choose our which stage we want to go forward with to assemble the engine. And we're also working on the intake manifold right now to choose which fuel delivery system we want to use.
Awesome. So walk me through, what were some of the major kind of milestones that you guys needed to hit as you progressed? So of course, you have a whole year to do this, right? What major milestones did you guys hit as you went on that kind of progressed to where the product is today?
Yeah, so first we got all the heads, and then we tested them on the flow bench, and that took about a semester to collect all the data on the heads and the flow bench, and then the compression ratios. And then this semester, we've been working on collecting more doing research to find what more parts we need, and then Rafa's mostly been working on the droplet analysis. Yeah, that's been the latest.
And next semester, we're going to assemble a generator together to get it running.
Awesome. So what were some of the major outcomes you guys saw so far as part of creating this project?
The major outcomes that we've seen is that we've discovered many different things about General Motors and different cylinder heads and how they function and the history behind it, and also why they gave up certain heads for certain reasons. And I think that was the most interesting and the most things we found about them.
Awesome. Thank you guys so much, and congratulations. All right, jumping next to our next group, and Alex?
Thanks, Trevor. So now on to our next group. Sorry, I hate to interrupt, but do you have time for a quick interview? All right, would you please introduce yourself?
My name is Faisal Al-Anizi. I am an ECE engineering, and my project is about a device for blind people. It's simply a sensor and a speaker. The sensor will send waves, and if the wave hits anything, like any obstacle, less than half meter, it will tell him that there is a near obstacle, so he can move freely for the blind people. And if any obstacle is more than half meter, it will tell him that there is a far obstacle, so he can move easier.
Was there anything in particular that inspired you to work on this project?
I think that because I think it's really a problem, and it's the solution for this problem. And maybe in the future we can make the device more advanced by changing the sensor. The advanced sensor can recognize the obstacle, if it's people or it's a car, and it can tell them that's a car, the obstacle is a car or people or anything.
Thank you so much. And what was your favorite part about working on this project?
The circuits, because I am an AC engineering, so I like circuits.
Wow, thanks so much. All right, and now we're going to walk over to our next group. We've had some really great projects today. All right,
we're going back across the pond one final time to our next group, which is a biomedical engineering group. All right, amazing. She's already ready for us. So really quick, introduce yourself and your team and tell us all about FormFix.
So I am Shantae, and I'm with Taylor, Michelle, and Catalina, and we are FormFix. We made a wearable technique and form correction device that's used for weight training exercises. And the reason why we made this device is because weight training has been found to have so many benefits, including reducing insulin sensitivity and increasing bone density. This is prevalent to us because there's so many health conditions such as cardiovascular disease, diabetes, and osteoporosis on the rise in the U.S., especially amongst the aging population. So we wanted to help people advocate for weight training exercises among all different age groups, and then we also want to make sure that they're doing the proper technique and form, because yes, there's all these benefits, but then if you're not doing the proper technique and form, there's an increased risk for injury.
Got you. So how does the actual device work? Can you kind of walk us through the process?
Yes. So what you will have is a t-shirt that will have snap pins on the shoulders and 2 points on the back, and MPUs, which are these devices that have accelerometers and gyroscopes that kind of are able to detect your place in space will be put into these snap pins, and they will monitor your position while you're doing the exercise. And while you're doing the exercise, say that you're rounding your shoulders or rounding your back, we'll have these 2 vibration motors, one on the top of your wrist and one on the bottom of your wrist, that will tell you, hey, you're rounding your shoulders, or hey, you're rounding your back.
Wow.
And then we'll kind of be like a little feedback for your mind, like, okay, I need to fix my posture when I'm in this position. And hopefully the more times that you're using it, then you won't have to use it at all because you're already having the correct posture while doing the exercise.
Very interesting. So where do you think this could go further? I know, of course, you're probably going into other things right after graduation, but if you were to continue with this, where would it go further? Where do you see the next path going?
So we would want to incorporate some type of technology that will make it a little bit less bulky. Right now we have a lot of wires, and then it's going to be connected to a laptop. We would include some type of Bluetooth, and then we would include a battery, and then maybe sensors that would be incorporated into the shirt, so then we don't have to worry about snapping it on, snapping it off, easy laundry, but then also maybe eliminating the laundry aspect in total and having some adhesive sensors onto the body that could be reusable, and then maybe charge it so then you don't have to worry about it too much at all. And then further on, we would not only incorporate this technology with Romanian deadlifts, but we would do with maybe squats, some type of bench exercise.
Okay, into the gym, I like it.
Yes.
Awesome. So what was, I see the passion for the project. What was your favorite aspect of working on it?
I think because I have been weight training for so long, about 6-7 years now.
Wow.
I was a former athlete.
Yeah.
Incorporating something that I'm super passionate about and then combining it with my education and all this knowledge and getting that little bit of like feedback from our professors. This is not the typical biomedical engineering project, but a lot of them are interested in. And then seeing so many people being relatable to this and encouraging people like all these benefits of exercising. Like, you can do weight training, but you can also do all these other things to improve your health. So.
Yeah. Awesome. Thank you so much. And congratulations. You were so well spoken. I loved learning about it. So congratulations.
Thanks so much, Trevor. So now on to our next group. We have Kane Go Mobile. Sorry, guys, I'm going to interrupt you for a moment for a quick interview. Would you mind introducing yourself?
Absolutely. I'm Theo Stykov. I'm an electrical engineer.
I'm Jimena Renteria, software engineering major.
And I'm Catherine Rose, a computer engineer with software focus.
And would you mind telling me a little bit about your project?
Yeah, I'll dish it over to the software, and then we'll come back to the hardware right after.
So now at the University of Miami, we use physical key cards, cane cards, to access buildings and classrooms. And now we consider that this system is inconvenient and outdated for students and faculty. So that's why we decided to
Create our app. It's for iPhones right now. It's called Kane Go Mobile. So this app is basically a virtual cane card. It connects to our hardware circuit, which Theo will explain, and you can unlock the door with the click of a button.
Yeah, and so their software skills were very much needed, and for the hardware, we used a Arduino BLE Sense, and it's we encrypted it with Bluetooth, and it's basically a mini computer. It's going to control everything in the project. So we're going to use one of its pins to send a signal to our MOSFET, and then this MOSFET is either going to send current to a solenoid or cut the current. And when the current goes to the solenoid, it's going to magnetize. And that magnetization is going to pull this latch back, and it's going to pretty much unlock a door. It's going to act like an unlocked door. And then when we tell it, when we demagnetize it, it's going to demagnetize this latch, and it's going to release it back to its original position. And we can show that here. It's a slight little... well, it's not connected right now, is it? Oh, it is. It is. And so right now it's unlocked with the blue light, and then once we lock it, it's going to become demagnetized, and this is going to move out of its sleeve. It's going to display a red light, and that's pretty much how we combined all our software with our hardware to create a new system so that we do not have to use cane cards anymore and can just work right through our phones.
Thanks so much, guys. What a really great project. And I personally love how applicable it is for students at the University of Miami. Now, if I can find Trevor, Trevor's going to take us on to our next group.
All right, so our next group is a group of industrial and systems engineers. These are some of the best industrial and systems engineers. I've had the pleasure of having class with all of them, so they're going to tell us all about their project with Global X. So really quick, introduce yourself and tell us all about your project.
Hi, my name is Delara Erklik.
I'm Lucas Bernabeu.
And I'm Vittoria Marinoni. So our project is based on a company called Global X that is based in Miami. we save them $3.7 million per year every time they conform 5 airplanes to their company. So what the conform of the airplanes to the company means is that when they lease an airplane till the moment that the airplane is about to fly or able to fly. So I don't know if you want to
basically, they would grab an airplane that's 12 years old, right? They wouldn't, since they're a very young company, they would have airplanes that come from Alaskan Airlines, from American Airlines, and these airplanes took 3 months and 2 weeks to be in the maintenance facility and the time where it was being conformed, as Vito explained. So what we wanted to make is basically find a way to reduce the time that this airplane was not flying, because for every day that the airplane wasn't flying, it cost them $50,000 a day. And from our results section, if you want to...
Yeah, so as Lucas said, essentially we were trying to reduce the amount of time that it took for them to complete the process. We came down from 83 days to 76 days in the process, and we also recommended to hire 2 more people to reduce over-allocation of tasks to specific employees. And finally, we, through our Visio mapping and identifying the problem areas, we were able to reduce the number of handoffs from 100 plus to 85. And as Vito mentioned before, we essentially save them $3.7 million per year, assuming that they conform 5 airplanes to their fleet.
Awesome. Well, thank you guys so much. And again, they did all of this in only a semester. So unlike some of the groups that get 2 semesters, they did this in 1 semester. So congratulations, you guys did amazing.
They're conforming. They're accepting all of our recommendations. So they're actually doing all of this. So the company's actually saving the $3.7 million.
As they should. These are some of the best engineers in the game. So, of course.
Thanks so much. And now, sorry to interrupt, guys, but do you guys have time for a quick interview? All right. Would you mind introducing yourself?
I'm Georgios van Vacas.
I'm Cesar Bernal.
Tomás Cepeda.
I'm Francisco Paredes.
And would one of you mind telling me a little bit about your project?
Alright, so essentially our project is called AirVOG, Aero Integrated Response for Volatile Organic Compounds. And the thing about the key characteristic about these compounds is that when they're exposed to air, they dissipate. So if a water body is contaminated, you don't just want to grab water from the surface, you want to make sure you're at least a foot down to be able to get an accurate reading. So that's where our design comes in. Essentially, with this design, this rod right here is a foot long, so once this part is fully submerged, this buoyant is going to float, opening a hole here that will allow water to flow in. As soon as you lift the drone up, this will go down. So this can all be operated just with this drone, so you don't have to take a boat and go off into the water. You can be from the shore and just fly everything. It's super easy, super simple. That's what we love about it. And yeah, that's pretty much it. There's also a magnetic seal, which allows us to make sure that prior to the point that we need to do the testing, no water gets in. And also while we're flying with these contaminated waters, nothing's being spilled out.
And was there anything in particular that inspired you to work on this project?
Yeah, so actually last year there was a big catastrophe in Ohio. So a train essentially derailed, which was carrying a bunch of chemicals, including vinyl chloride and VTX compounds. These are considered VOC chemicals. So when it came to the testing for the monitoring of what was going on, it was very sporadic. So you had tests every couple of days, and also sometimes it will be only 1 test per location. So we thought that if we really want to be able to keep track of these catastrophes and make sure we're properly handling the contamination, we need a really fast, quickly, and simple way to keep track of the monitoring. So that's where this idea came in. With this, like I said, you don't need a boat. All you need is your car. You drive there, you fly, and you're good to go.
Thanks so much. What a great project. And I love that it has so many real-world applications. Now, Trevor's going to take us to our next group.
Awesome. So we only have 2 more groups left, folks. So going over to our next group, who is Quad Force. Really quick, Cam, introduce yourself and the rest of your team and tell us all about your project.
Hey, so I'm Cameron King. This is Felipe, that's Nico, and that's John. And together we're Quad Force. And so our device is a way to quantify the percent strength you have back in your quad following ACL reconstruction. And how that works is we'll take these ankle weights, put them on the injured leg along with the device, actually healthy leg rather, and then we'll put as much weight as we can on that healthy leg and get to you around 160 degrees, so not fully extended. And then we'll take that same amount of weight, put that on your injured leg, and the device will then take both of those angles, run it through that equation right there, and then spit out the percent strength you have back. And the reason we're looking at the Quad Force is that is what most surgeons and physical therapists are looking for in their patients so they can be returned to sports. And most of them are looking for around 80% strength recovery.
So that's why we focus on the quad, and the quad is also one of the first muscles to really lose all that strength. And yeah, so that's why we're looking at the quad, and that's quad force for you.
Awesome. And what were some of the major outcomes that you guys found as part of the project?
Yeah, I would say the biggest outcome would definitely be getting as much accuracy as we can. So as you can see right here, this is a test we did right here without it moving at all, and the percent was 100.00. So that's really precise, and we were really impressed with how precise the device actually was. And then you can also see on our test here, we ran a manual test and then manually crunched the numbers. So we took a knee protractor, quantified the angles using that, and then manually did those tests while the device was on, and then we compared those results, and as you can see, the results were really promising.
Awesome. Thank you so much, you guys. Congratulations. All right, heading over to our final group.
Thanks so much, Trevor. So for our last group of the day, hi guys. I'm sorry to interrupt, but we're just going to do a quick interview. Would you please introduce yourself?
Hi, I'm Eduardo Chavez.
I'm Hernan Aviles.
Anna Velasquez.
And would you tell us a little bit about your project?
Yeah, of course. We're converting electrical signals from plants into MIDI data that can be used to control virtual instruments. So what you're listening to right now is being controlled live from this plant.
That's really cool. What inspired this project?
So actually our team member, Eduardo, he had a music producer that he really liked. He saw that he was taking electrical signals from dead rats to make into music. So obviously we wanted to do something that was a little less invasive, so we did it with plants.
Wow, that's really fascinating. Now, could you tell me your favorite part about working on this project?
I think overall, just making music out of plants. I think that's really cool, and I think that makes our project really stand out.
No, what a great project to end on. Thank you so much, guys. All right. It has been a really great, so many great projects today. Trevor, what do you have to add?
Honestly, like I said, been here 3 years, and every year I'm continuously blown away by all the projects. I think it's one of the coolest things. As you see, some groups are creating their own projects, new ideas, and others are already working with other companies, right? No matter what route they go down, no matter what, right, they're adding a lot to whatever company or whatever idea they come up with, and that's one of my favorite things. So a lot of these engineers, right, even though they're seniors in college, they're making lasting impacts no matter what route they go down and what discipline, and that's by far one of my favorite things always to see during the Senior Design Expo.
What I've loved so much about today is to see so many underclassmen get involved. I've seen so many underclassmen walking around, so interested in the projects, and for me, it's just really inspiring. As someone who's going to be here, I just think so many of the projects are so fascinating, so many different applications, so diverse, and I've just had such a great time. Thank you so much for joining us today. We're going to take a quick break, and then...
Yeah, so we'll be back at 7 p.m. But in the meantime, thank you so much for watching the live stream. We've had a pleasure hosting and going to all around the groups. Next year, you're going to see Alex and I, so we won't be hosting, but thank you so much for joining us today. Thank you.
Senior Design Expo 2024. So I'm going to ask the Dean of the College of Engineering, Dr. Biswas, to please come forward.
Wait here. Hello, everyone. I hope you all enjoyed it. Did you? Loud cheers for all our students. And class of 2024, congratulations. So let's give them another big hand. Lot of exciting things happening in engineering, lot of tech initiatives. So those who are visiting, please stay in touch. We do this throughout the year, right now. And come back next year, even though you're graduating or your son or daughter is graduating, do come back. This is a fabulous event and spread the word. I'll keep my remarks very brief. I'd like to, at this time, thank all our sponsors, the Alumni Association, College of Engineering. I think I saw the folks from the committee. Are they here? UM? They'll come up here. You'll get to see them. Ryder is a sponsor, FPL, and they are capstone partners. And there were many companies as I went around, many of you indirectly sponsoring. So thank you very, very much. And next year, please spread the word and come back and support our wonderful students. I would also like to thank the Expo committee. This I do, right? Yeah. Yes. Yeah. Of course, Nina, where did Nina go? Nina has been fabulous. She makes all of this happen. And then, of course, you have Julian Lipman. He's somewhere around. Right there, please come up. Gang Wang, I saw him. Gang Wang, please come up. And Gang, I'll mention this, I'll put you on the spot. His daughter is here. So, daughter, your dad has been superb, right? Samuel Amin from Chemical Environmental Materials Engineering, he's here. Hamam was somewhere around, Hamam. And then, of course, Ines Basalo. Let's give all of them a big hand. Yeah, okay. Thank you very much. I'll thank the faculty judges. Courtney Dumont, I saw her walking around. I hope she's around. Luis Pestana, Dibyendu Mukherjee, Kamal Premratne, Yehu, and Bertrand Deno. Let's give them a big hand. And students, you might recognize them. They stood at your thing and we were probing a little longer because they have to score you. So thank you again, all the judges, the industry judges. Alan Sirkin, I think he's here somewhere. Alan is also head of DAC. Alvaro Ruiz, Maggie Giraldo, and Ileana Barbara. I think I met some of them here. Walking around. Thank you very much. Yeah. And there's another page. Fiorella Lopardo, Hector Maestri, and Gabriel Elias. Thank you very much. And to all my faculty colleagues, this has been just great. We will now play a message. President Frank could not be here, but he sends his best wishes. And he would always come here. This time he got tied up. So let's... Yeah. How do you turn it up? This one. Yeah.
Feel the excitement of
Oh.
Thank you, Ms. Ross. On behalf of the University of Miami, it is my pleasure to welcome all of you to the 2024 Invest in Your Future Senior Design Expo. Though I cannot be with you today in person, I can feel the excitement and pride that is in the air this afternoon. I am continually amazed by the ingenuity displayed by our students in the College of Engineering, especially our seniors. And I know you will feel the same as you partake in the thrill of discovery when these students unveil their hard work, creativity, and innovative solutions. Today's Senior Design Expo represents the culmination of years of hard work, innovation, and dedication from our students. It stands as a testament to collaboration, demonstrating the preparation and achievements of these young men and women before they stepped into the wider world. Soon, these talented seniors will graduate and embark on careers dedicated to crafting solutions for the world's most pressing challenges. To our graduating seniors, without a doubt, you stand prepared for whatever lies ahead, and you will always have the unwavering support of your UM family. Your boundless creativity and dedication serve as a beacon of inspiration and hope for a bright future. Congratulations to each of you on your capstone projects, and thank you all for participating in this event. Go King!
Okay, that's over, right? I'm done? Okay, thank you all again, and I'm turning over. There's some more exciting announcements to be made, prizes, I guess, to be awarded. So thank you again all. Next year, do come back. It's also the 100th year of the university, right? Yeah, so do come back. We'll have a special show.
All right, so the first award that we're going to present is the best project, and Dr. Lippman will do that for biomedical engineering.
Hello, everyone. How you doing? All right. It's my pleasure to announce the outstanding biomedical engineering project for this year. And the outstanding project is Nalox, near you. Come on up. Come to the stage. The faculty as well should come.
The senior design faculty who mentored them, and Dr. Mons.
If available.
Mr. Sirkin, can you please come to the stage, and he will be announcing the Civil Architectural and Engineering Award.
All right, you can still do it. Okay, let's see what's ahead. So civil engineer, so that's the winners?
Yes.
The ace. Yeah. All right, so you ace people, you want to come up and get a picture taken? You'll have it for the rest of your life. So. I guess I get in the middle. You want me in the middle? Let me get in the middle, I guess.
Good, good.
So I know you all worked hard, and wishing you a great career as the world goes on. Keep those buses running. So good.
Thank you.
Yeah.
Thank you.
Good luck. Good luck to you all in your future.
Thank you, Mr. Sirkin.
All right, everyone. So again, it's my pleasure to announce the outstanding award for the Chemical, Environmental, and Materials Engineering Department. So the winner is, the winner is, for Chemical, Environmental, and Materials Engineering, is Civolutions Consultants, University of Miami Stormwater Management, Design and New Engineering Building. Come up and Professor Chin, David Chin, and Professor Wu. Oh, you're already here, David.
All right, so now it's time to announce the winner for the Electrical and Computer Engineering Department. And the winner is HAR, Home and Roommate Platform. Come on to the stage.
So now for the Department of Industrial and Systems Engineering, the best award goes to Global X. Dr. Vitrigo, you come up too.
Hello. I am super, super excited to present the winner for the Department Award for Mechanical and Aerospace Engineering, and that goes to the hybrid flow airfoil. Guys, where are you? So, Dr. Yang, are you here for the picture? Dr. Swain? Who was your faculty advisor? Dr. Dano. Dr. Dano, come up for the pictures. Um, so now we're gonna start with the awards that were decided today, right? Based on what you submitted on the online platform, based on what you brought with you today, based on the judges' opinion and their voting. So we're gonna start with the best expo display, and that goes to, guys, don't go too far. You got another award. Do we have
another picture or?
I guess another picture? No. Yep. Awesome. Okay. So now we go for the best poster, and that goes to CareMax. This is your department, right? So the CareMax team. I'm not going to be in that picture. It's not my department. Yeah, it's industrial. It's not my department. Good. You know, I like this because it's. So one more now for the best expo video. These videos are the ones that you submitted to Huva. And that award goes to Muscle Memory. Mom, that's ECE, right? The Muscle Memory team. Oh, here you are. And then, well, I'll call you. No. What do we have after this? You introduce Alvaro? Yes. Well, why didn't I introduce? You want me to introduce him? Okay. Okay. So now I want to invite Alvaro Ruiz Esperanza. He is the president of the Alumni Association. You will soon be a member and consider an alum. So Alvaro is here to present the People's Choice Awards. Those are the ones selected by the attendees. So when you voted for your favorite project on your phone, those are the awards that you'll get now.
Okay, thank you, Dr. Basalo. Good afternoon, everyone. I'm here really honored to be representing the College of Engineering Alumni Association and also to present an award that we actually are very proud of because we sponsor it as alumni for you, the students. So this is the People's Choice Award. We have 3 awards. Third place with a $200 check, which is not bad. The second place is a $400 check. And the first place is actually $600 check, which is a great gift, which I could imagine you would like to win. So, so before we get into the awardees, I would like to congratulate you all. I've been one of the judges. I'm impressed with the work that you've done, the innovation, the creativity, the way you have tackled the different problems that you had to solve. So, and with that, I would like to also let you know that, yes, I mean, you've had a great family as you were students, but that family, that Keynes family, continues once you graduate. And that Keynes family continues as an alumni. And with that, you have the College of Engineering Alumni Association, which is this great organization that is going to take you through once you graduate, and it's going to foster your relationships among the UN people. So without further ado, because I know everyone is excited and you want to know who won and whatnot, I'm going to present the 3 awards. So on third place, we have ABG Now and GlobalX Airworthy Compliance. So it's a tie. So we have a tie, so we'll need to share the check. But can you come up to to the stage, please. Okay, so let's go here. This is what you get. Okay, now for the $400 check, the second place, we have a stormwater management system and UA College of Engineering campus expansion. So please come to the stage. Congratulations. Congrats, guys.
Thank you. Thank you.
Congrats.
Thank you.
Congrats. Okay. Stay a little bit. Thank you, guys. Okay, so now we have the big check, $600. Are you guys excited or not? I don't see a lot of excitement. Yes? Okay. All right, $600 is not bad. Come on. Okay, so the winner, the first place of the People's Choice Award, is FPL 1-volt bracket. Okay, so I know you are guys all excited, but I want to let you know that the excitement continues because I told you that the College of Engineering Alumni Association wants to have you in the family, and we are going to do a great welcome today at 8 p.m. at the faculty club to celebrate you, to welcome you to the club, to welcome you to the Alumni Association, and to have a great time and network a little bit. So please join us, 8 p.m., Faculty Club. It's right across the little path next to the Shalala. So we wait you all there. We'll have some wine and cheese. It's going to be amazing. Thank you.
Thank you, Alvaro. So now we're going to have Dr. Sam and Lokesh come up. And they have some other awards to announce.
All right. Hi, everyone. This award is for the College of Engineering Rothberg Catalyzer Pitch Competition. No, not yet. Okay. The third prize is $10,000. The second prize is $20,000, and the first prize is $30,000. Bigger check. So the first prize, I'll go with the first prize. First prize goes to Simu Stride. The second place goes to ABG Now. Congratulations again. The third place goes to Citrus Mimic. Congratulations, all the winners. Thank you. Congratulations.
Dean Biswas, you have the last two awards to announce.
Yeah. I just announced it, right? Yeah. Okay, now we have the last two awards. Industry Impact Award. The Industry Impact goes to FPL 1-bolt bracket. Do they get something? Okay. Good, yeah.
Thank you. Thank you.
Congratulations. Hey, last guy gets the check. No, yeah. Yeah. And the very last award, but a very special award, named after Dr. Shihab Asfour. I think he was one of the brainchilds behind this, for the best senior design project for the College of Engineering. And the winner is hybrid flow airfoil. No. Same. Okay, I'm going to sneak in. That's it? Yeah, you close it, yeah.
So I wanted to thank everybody for coming tonight, and please do not forget that the Alumni Association is hosting an event for the seniors, free food and free alcohol. It's at the faculty club, so as you walk down, you walk across, and it's right there. No excuses for not going. I hope to see all of you there. Thank you for coming, and we'll see you all next